In this question, the mass is 1 kilogram and we're falling from a height here. So here's my ball. It's falling and it's hitting the ground. So it's falling from a height of 40 meters. So we have S is equal to 40. It starts from rest. We're going to find the speed hitting the ground here. V is equal to V, and it's falling under gravity. V squared is equal to U squared plus 2AS. So my V squared is going to be my 0 squared plus twice G times 40. So V squared is going to be 80G. Leaving V as the square root of 80G, which actually works out evenly. That's 784. So V is going to be equal to the square root of 784, which you've all learnt off to be 28 meters per second. Now that's going to be minus 28J. It's coming down. So the speed which it first rises, and we're given coefficient of restitution is a half. So the new over the old is equal to minus E. So 2x is equal to 28. So it rises with an initial speed of 14 meters per second. It's going up plus J. And we're asked for the height it reaches after the first bounce. So it bounces back up. So we have speed, the initial speed of 14. It's going to stop when it climbs a little bit. How far is it going to go? And what's the acceleration here? It's going to be minus G, dragging it back down. So VUAS again, V squared is equal to U squared plus 2AS. So this 0 squared is equal to 14 squared, and G is minus, so minus twice by 9.8, which is 19.6 times S, and 14 is 196, so 19.6S is equal to 196, so S is equal to 10. So and we're dealing in meters here. Big bounce, 10 meters back up, bouncy ball. In this question, everything is in terms of G, H, and E. So just do it exactly the same way. Don't let in terms of make it any more difficult. So a ball, I was going to say a man of mass M falls from a height H, but it's actually a ball. Mass M, height H, onto horizontal ground. So here's my height H, falling from this point onto the ground. And we have mass M, the coefficient of restitution is E. So the speed upon hitting the ground. So it's starting from rest. We're looking for speed. It's accelerating with a force of gravity, and the distance is h. So v squared is equal to u squared plus 2as. So we're going to have the speed being the 0 squared plus 2gs. So we've seen this before, where v is the square root of 2gs. The speed with which it first rises, so this is where the coefficient of restitution, so the new speed over the old speed, square root 2gs, is equal to minus e. So the new speed is equal to minus e times the square root of 2gs. And hope you're telling me it's not, because this one is going to be a minus because it's coming straight down. So we get e is equal to the square root of 2gs. X is equal to the square root of e times the square root of 2gs, to be more accurate. And then the height it reaches after its first bounce, so it's going back up in the air. It's going back up in the air. A is going to be equal to minus g. The new speed, u, is equal to e times the square root of 2gs. It's going to stop before falling back down to earth, and we're asked that this the height that it reaches, so we'll call this h, the height. So I think all we can do here is plug it into the formula. V squared is equal to u squared plus 2as, and see what we get. So 0 squared, it's going to stop, is equal to u squared, which is e squared by 2gs, if you square this guy straight away, and then plus twice minus g times s. So 2gs is going to be equal to e squared times 2gs. 2gs, e squared, 2gs. Just let me go back and change what should have been h's back here, just to be better mathematically. That's 2gh, making this one h and this one h, because we were given the h originally, and we're going to use s now. which would make this one in here a h. To separate it from this s, we can't use the same variable. So that's going to be my h there. So s is equal to 2e squared gh divided by 2g. And you can see that's going to be equal to e squared h for the distance traveled on the way back up.